Alright, so because both sides have e and have a value in front of e, when you take the natural log of both sides, you're going to rewrite these, okay, with your property rules. Do you guys know what property we can use? Nope, if there's quotient, there'd be division. What operation do I have in here? I have multiplication. So what we're going to do is we're going to rewrite with the product property. So rewrite with the product property, which means if these two are multiplied, I can rewrite it as the natural log of 20 plus the natural log of e to this power. On the other side, I can do the same thing. I can do the natural log of 52 plus the natural log of e to the power of 0.064t. How is that going to be helpful? Yeah, let's cancel out our inverses. The natural log and e, don't those cancel each other out? Yep, so if I cancel that out, I have the natural log of 20 plus 0.07932t. That is greater than the natural log of 52 plus, and then here's another natural log in e that I can cancel. And now we can move things over that are similar. So see how I have two values with t in them, two values with the natural log? This is just like algebra where you want to get all the variables on one side, all the other values on the other. So even though these are natural logs, remember, these are just decimals, right, that we're going to be moving. So if I want to get all of my t values on one side, I'm going to try to move my t values over to the side where I don't have to divide by a negative. So let's do that part first. Okay, so we're just going to subtract the coefficients. So I have 0.01532t. And then you can do this in 2 steps or 1 step. So you could bring down the natural log and the natural log, but really you're just going to end up moving the natural log of 20 over. Okay, so on this side, these canceled, right? So now I have the natural log of 52 minus the natural log of 20. On that side, those canceled out. Okay, now once you get here, you can rewrite that with the quotient property if you want to. You don't have to. Okay, so I'm just going to keep it like this. Yeah, you could rewrite it as the natural log of, in parentheses, 52 divided by 10, but you don't have to. Okay, you can just go ahead and divide this, which is honestly what I recommend, because I don't want you to accidentally combine something incorrectly here. Okay, so when you are putting a fraction, a division in your calculator, if you are doing all of this at one time, you are going to have to put parentheses on the numerator because there's two things there. Another way to avoid that, if you're putting it all in at one time, you need your parentheses. If you are nervous about your parentheses, because sometimes I get nervous about the way I put it in, so what I do is I'll just do this part first, the natural log of 52 minus the natural log of 20, and then I'll take that and divide. Okay? And then this one did say to round to the nearest tenth, so that 3 gets bumped up to a 7. And then what is the t value in this case? What unit? Years, minutes, seconds. What is it? Minutes. Okay, so that's something that you want to label. Okay, so we know that bacteria A cells will be greater than B, okay, when the time is greater than 62.4 minutes. Okay, and that's probably the most in-depth one that we'll do today. Most of it is going to be like step B, okay? Yeah.
We haven't done one where we didn't have a form like that.
Really didn't? Yeah. I wanted to go over it so that you knew how to do ones like that. Okay, now the continuous exponential decay function is almost the exact same. The only difference is because it's decay, in the exponent you have a negative. Okay? Now your A is still your initial value. Your T is still your time. The units will vary. But your K value is now called the decay constant. And that is something that you will have to find often. In some cases it will be given to you. And this exponential decay function is something that you'll see in your next math classes as well. If you ever study like half-life in your chemistry classes, because it uses chemicals, the carbon-14, there's like artifact dating. You'll do an example with that in your homework. You will use some variation of this formula. So for example 3, it says chromium-51 has a half-life of about 28 days. So let's make sure we understand what half-life means. Okay, so the half-life is just going to be the time it takes for the substance to be cut in half. Okay, so the half-life is the time it takes for a substance to be cut in half. So let's think about chromium-51, okay? So that has a half-life of about 28 days. So let's say I start with 100 milligrams of it. After 28 days, you would know how much is left. 50, right? If I started with 10, how much would be left after 28 days? 5. So this is always the amount of time it takes for whatever value you have to be cut in half. Okay? No matter what value you start with, it's always half of the original. Okay? So this is to determine the value of K and the equation for this element, the chromium-51. Alright, so when you're trying to find your value of K, you are going to use the time they give you, the half-life, and then sometimes they will not give you an initial value, okay? You can see in part B, they say how much of a 650 milligram sample will be left. You could use that as your initial value if you wanted to, but another value, you can use anything that you want. And I'm going to talk to you about what value I think is the best, and then you can pick whichever one you want. Okay, so if no initial value is given, you can choose. okay? So if they don't give you a value, you can choose. So what I like to use for my A value, I can see this is going to be in milligrams, okay? So I would use 1 milligram. So if I start with 1 milligram, after 28 days, how much do I have remaining? Yep. Okay, so if I choose 1, then I know I'm going to have half after 28 days. So if I plug that into my equation, okay, then I know I have 0.5 or 1/2 equals, my initial value is 1, e to the power of negative k times 28. Alright, let's say that you didn't choose 1. What's another value that you guys want to check out? You don't have to write this down, you just have to pay attention. 5? Okay. So let's say I start with 5 milligrams. Okay? If I start with 5 milligrams, then after 28 days, how much would I have left? 2.5. So if I wanted to solve this for E, what would I do first? Yep. What's 2.5 divided by 5? What's 2.5 divided by 5? 1/2 or 0.5, right? Is this equation exactly what I have here? Yep. So wouldn't that happen no matter what you told me to start with? Because whatever you choose here is always going to be half of it here. So if you can pick any value you want, but you're always going to end up with this. And what's 1 times anything? Itself, right? Okay? So once you use that, when you take your natural log, 1 times e is just this. So I'm just going to do the natural log of e. I don't have to worry about the 1. I don't have to divide by the 1. You would just get the same thing. And now you can cancel out the natural log of e. Because of our power rule, this comes down. And your last step is going to be to do what to both sides? Yep, you always divide by that coefficient. Right? So again, you want to round to 4 significant figures for your k. So you can do the natural log of 0.5 or 1/2. Alright, so this is going to be 0.0247, and then that's going to bump up to 6. So this is part of what they asked you to do, and then they also asked for the equation of decay. And so you can use f of x or you can use y, it doesn't matter. But they didn't give you an a value yet, so you are going to keep that as a. And then don't forget that when it's decay, you have to put the negative in there. Okay, you also have to say what t is. So t is the time in what? In days. Good. So you have your k value, and then you have your equation, your model. Okay, so now we're going to use that model to help us with part B and part C. So in part B, it says how much of a 650 milligram sample will be left after 30 days. Okay, so your initial value is the 650. Your time is the 30 days. And so when you plug in 650 for A and 30 for T, you can see this is an evaluation problem. Okay, and again, if it doesn't tell you what to round to, you can choose, I usually choose the nearest hundredth or the nearest tenth. And then just double check that you're putting your decimals in correctly and that you are labeling your units correctly. So if you want to know how much of this sample is left, what should be my units on my 309.26? Yep, your milligrams. Good. All right, and then part C is asking you how long it will take that 650 milligram sample to decay to 200 milligrams. And then you're going to round that to the nearest tenth. Anytime it asks how long, we know we're finding T. Okay, so you're going to find T. Your initial value is going to stay the same. Okay, and then it wants to know how long it'll take for it to decay to 200, so that's going to be your value for Y. Alright, so I want you to go ahead and solve for part C. You can round to the nearest tenth there. Alright, so whenever you have E, we know we're going to be using the natural log. Before you take the natural log, you want to make sure there's nothing in front. And then, again, you can reduce. Like, that's an easy thing to reduce. You can go further if you want. You don't have to. The main thing, I'm just looking for work that is easy to follow, organized, written out nicely. Okay, and then you're going to divide by that value. And I'm okay, like, at this step, if you just put that. I really want to see, like, this is what you're plugging into your calculator. Like, this would be your exact value there. Okay, and you should get 47.6, and then did you remember to label it with the unit? Okay, so this one is in days. Alright, now, the last one that we're going to do is another half-life problem, and lots of half-life talks about radioactive substances. So this radioactive substance has a half-life of 24,110 years, and then did you notice that they gave you the decay constant for this one? So you aren't going to have to find that. So for a few of them we have been finding K. Sometimes they will give it to you. What they do give you is a percentage. It says how long will it take 75% of the to have 75% of the sample remaining, and we're going to round that to the nearest year. Okay, so for part A, again, you do not have an initial value. So you can choose whatever you want. It does not matter. You could even just call it A, okay? So the original sample or the initial value is A. If you want to find out how long it takes for 75% of it to remain, how would I write 75% of the original? 0.75 what? A. So if this is my original sample, again, you can plug anything you want in for it. Okay. For this one, I'm going to show you how you can just do it with A, and then you're just going to solve. Okay, so this is how much is remaining. So this is how much we would plug in for Y. A would be the initial value. And then because this is your decay constant, you're going to plug that in. 1, 2, 3, 4 zeros there. And you're trying to find T. Okay, so your first step is always to divide what is in front. And if I divide both sides by A, what happens? Yep. That's why it doesn't matter what you choose. Because no matter what you choose, they're always going to divide out to be 0.75. And then what's your next step? Natural log. Okay, so we do the natural log of both sides. Okay, and again, I'm fine with you just doing this here and then writing it on this side. What I'm really looking for is this. I want to see the division. Okay, I want to see this natural log of 0.75 over that value. That way I know exactly what you're plugging into your calculator. That way you know how to write this as an exact value. And it says round to the nearest year. Okay, so that means you're going to use your decimal. The decimals 5 are up. You round up. 4 below, you keep it. Yeah, oh, sorry. So I'm just doing the natural log of 0.75. And then this I'll put in all at one time.
Yes, that's what I got. Okay.
Oh, thank you. I was like, what did I do?
That's a long time.
How do you copy and paste?
So if you have a calculator like mine, you can highlight it.
It was supposed to be negative.
And then go to insert. Yeah, but that's a good thing, because what do you think people forget most? Yeah, and that's because when you're doing this, this is your equation, right? So when you're plugging it in, your y, your a, the negative goes in front of k, always, for the k. Now I must color code my negatives. Alright, now you should get the same thing, just positive form. So if it's 0.7, that's going to do what? Round it up. So we have 10,024 years. Okay, and then part B is very similar. There's just a few language changes in there, so I want you to read that and see if you can come up with your equation. Okay, so again it says find how long, so we're still finding t. Okay, but it says how long does it take to lose 75% of the original sample? So a 75% loss is the same as what? So 25% remains. That looks like last, but it is lost. Okay, so if there's a 75% loss, that means 25% remains, which, yep, you're going to write that as 0.25. Now remember, I said you can choose your original sample as anything. So a good thing to choose for your original sample would be 1. Okay, so if you say that your original sample is A is 1 and 0.25 remains, okay, then what's going to be your value for Y? just 0.25. Again, you could use the A, that doesn't matter. It's just if you use the 0.25, you don't have to divide by anything. Okay, 1 is going to be the same thing as if I were to write e to the negative 0.000287t. Okay, so when you take the natural log of both sides, you have the natural log of 0.25 equals and then you just have one more step. And then again, we're going to round that to the nearest year. And then again, just be careful with the decimals because those are easily lost. So it's 0.9, so it's going to round it up to 48,303 years.
My kids aren't going to.
Okay, and then, so your homework tonight, I'm going to put up here, and then we're going to go over your 8.3. That is what was due on Friday. And then I know some of you are gone with a school trip, so just have that in by tomorrow, okay?
Oh, let's go. Is that all?
Not, yeah. Yep, so it's just, yeah, the one.